welcome you guys to my channel. So once again, this wasting technology. So it's been long that I've worked on Python. Actually, I've been a bit busy working on some projects like that. So I come back to proceed from where I stop. So stay tuned and don't miss out. So in this course, we are going to be studying sets. So sets before we dive into dictionaries, but sets very important. We are going to go in depth of sets, then from there we proceed to dictionary in the next class. So without wasting much time, we're going to change sorry, I'm still going to use this my stuff here, but I'm going to create a new file. Okay, so I'm just going to create a new file and I'm going to call it sets.py, like that. So we have created a new stuff and we call it sets.py, which is here. So I'm just going to close this and close this. So we have only this available. So now first of all, we'd like to introduce what set is called. Set is another data type. As we know earlier, we have discussed about a lot of data types that are includable, that can store multiple data, such as lists, sometimes called array, sets, dictionaries, tuples. So this time around we are talking about sets. So why lists and tuples are ordered lists? They are ordered intervals, ordered variables that store multiple data. Sets are variables that stores data in an unordered manner. So whenever I store maybe 1, 2, 3, 4, and I'm trying to get back my 1, 2, 3, 4, I might end up getting something like 2, 4, 1, and 4, something like that. So the data are not always in order. Why is it so? Because they don't have index numbers, just as lists and tuples that you can access them using the square brackets like this. For instance, you can see my list, then I access it with index 0 or index 1 or index 2 or index 3 or whichever index. I can do that, but on set we can't access using set. So I'm just going to let me zoom a bit so get to see what we're doing. Very important. So what are we actually looking at to do here? This. So that is the first thing we need to establish about sets. Now the second thing is set items are unchangeable. You can't change them, unlike arrays that you see, or lists that you see, maybe my list, then you assign it to something like 2, 3, 4, then later on you come and change the value of 3 to something like 6, or 3 to something like, by just running my list like that. Then you look for the index number of 3, which is 1, then you equate it to something else like maybe 9, like that, and you go to the next line and print your value of my lists like that. So like something like this, we can do, and you go ahead to run this. You go ahead and run this. Sorry, let me run it here. Python set.py. So you can see in our stuff here we have 2, we have 9, and we have 4 in this place. So you can see that. So but in set we can't change value. We can only add, remove, and update with another set. So that's one thing we should know. Set items do not allow duplicates. So I'm not just telling these rules, but I'm going to be proving it. So now, how can we write a set? How can we create a set? So there are 2 ways in which you can create a set, and the first way, a common way, so I'm just going to call this sets 1. The first way of creating set is to use a curly bracket like this. So use a curly bracket like this, you have created a set. So I created a variable called set1, then I assigned it to open and close curly braces like this. So I can put any kind of data. A set accepts any kind of data. Even you want to pass in the data on its own, it accepts it. It accepts numbers, which are integers. It accepts strings, which are text, and accepts what's it called again, booleans like true and false. Accept that. Accept tuples. Can pass in tuples. You can also pass in lists and all that inside, and which is very cool. So let's try to see some stuff there. The first thing we're going to be doing here is I'm going to call this. So I'm just going to pass this with numbers like 2, 3, 4, and let me pass a text like wasting, like that. So you can see we have values in our stuff here. So you can go ahead and print it. So I want to print set1 like that. So you can see what we have there. Over these variables we have set1 is what? The set. You can see set is highlighted. It's trying to tell you that it's not just any ordinary value but a set. So you can go ahead and run this, and you can see now, you notice the first proof of what we have been talking about. When our answer was printed out, you notice that we have wasting. Wasting comes first, 2 comes next, 3 comes again, then 4 comes next. Now why is it like that? It's just like that because actually the letters come first, then followed by numbers. Actually numbers were arranged properly, but if we have pile of text, words, they won't be arranged. So I'll run this again. You might end up having okay, you can see this time around, you see we have 2, we have 3, we have 4, then we have wasting at the end. So that is the only 2 ways this can change, because there's remaining ones are numbers except this, which is a text. So if I run it again, it might still give us the same one or give us the previous one. So you can see just like that. So these are the 2 types of stuff that can happen here. But what about if we have another word? I call it Watin, and I call this throw like this. So I've passed in a string, passed in a boolean, passed in an integer, passed another string. So this true is still the same thing as me saying 1 in case you see 1 printed out. I'm gonna run this, and you see we have true here, we have 4 here. See, it's not the way it is being arranged here. Here Wharton comes first, but here it's not arranged. You can see we have Wharton, Wisting, 4 and all that. So if I run it again, you see that we have true, Wharton, and everything is just scattered. It's presenting it randomly. So whenever things behave this way, there is no possible means of accessing those information in their order using index or using whatever we think of. So that's the first rule we need to take note of in sets. So I said that you might wonder, okay, so then how do we access, maybe want to access elements or individual elements or so? Well, I can say by pointing them out. Sometimes we use integrables like loops to loop through each information. So I can just use a for loop for x in set 1 like that. I can now say print. So if I say print x, this is going to print everything one by one. So I can just print. You can see we have through, Wharton, for Wisting. Now it's printing it this way. So if for instance I want to say, let me print one of it, maybe access true, that would be impossible, although we know that the index value of true is 1 in this content, but might end up having something else here, but sometimes it end up not running. So let me run that again. See, we can't even iterate through this sheet. That's the problem. We can't do that. So you see what's trying to talk about here. So that's the way you can access individual elements. We can't do this as we do in sets and as we do in other stuff like that. So I'm gonna get rid of this. So okay, let me try something. Let me change this to 3. Okay, let me see if that works. 1, something like that. So let me try to run that again. So still bunch of errors, more errors are coming up. So I want to get to see that. Let me clear my terminal. Okay, so that's for that. I told you again that set does not accept duplicates. So if for instance we have Wisting here, and I now add another thing like 4, number 4, add number 4 again. Let me see what's going to happen. If we have 34, we'll try to run it. Sorry, print set 1. So let me see if that works. So you can see after printing the stuff, we have more than how many details here? Only Wisting, 3, 4 and Wharton was printed out. The remaining 4, which is this 2, 4 I added at the back, was ignored because they are duplicates. We have 4 already, so we can't be adding extra 4 to it. So that's it. also did a short proof as of the stuff, everything we have talked about sets. So now, what are other things you can do with sets? So if for instance I have a lot of data inside here, I can add enough info on it, so I can say listing put technology. I can put company. I can put coding, like that. So now we have all of this, so I can look for the total value or total length of what we have by using a len function to do that. So I can just come here to create I just create a variable called total. I just want to make things look neat. Total, then I have length of my set 1, just like that. So in here I'm just going to put total, and that settles the case. So if I go ahead around this, you can see it's giving me a total of 4, which we have here. Number 4, which is 1 listing, technology 2, company 3, coding 4. So it's giving me total length. So this is one of the stuff we can also apply to it. We can also check the type of information we are getting. On a normal note, if I check this total, it should return an integer, which is this. So this is another way of doing that if we don't have a suggestion. So we have type. I can do type. If I do type of total, it's going to return an integer for me. I think it's becoming one. Set 1. Okay. Set.py, mistake. So you can see we have a class is an integer. You can see that over this place, class is an integer. That's for total. Whereas if we change this to set 1, I mean, not set. You see, we refer to as class here is a set. So you can see that I explained earlier that there are different ways you can present this information. So another way of doing that is using the set method. The set method to do that. You can just get rid of this and get rid of this. So to use the set method, I just copy all of this, pull them away. Now we've created a variable called set1. Okay, instead let me leave that there. Pull this out. Okay, so let me create another one and call it set2. Set2. So I'm going to assign it to method which used to create another set. So we call it this set. So this set class which have a method called set. So it's not an object built on another collection of unique elements. So it's still the same thing. So without using that, you can also use this. So it's interval set object building on other form. So you can put a square bracket, then you pass in your information. So I'm just going to pass in my information that I picked from here, so I can still pass the same stuff here. Copy it and paste it here. So just like that. So I don't need this can go ahead and print set2. So you can see when returning it returned it the way this was being presented, or this was being presented to us. So you can see that. So that's for this. Another way of presenting sets. So what about we present the two in a similar way? I change the first one to 1, set1, which picks this first part, and this to set2, which prints this second part. So if I go ahead, let me see. So I want to print both stuff there. So I'm just going to run this. You can see. You see the first one have coding. Next one is technology. But this one coding on top, coding button. We have technology on top, but we don't have technology under. But we have company. Here is company. Here's technology. Here's wasting. Here's wasting. So those two parts they kind of interchanged. So we don't know what might happen. So you can see if you run it again, you might get the worst out of it. Wow, this almost run the same stuff. Well, that's lucky. You can see I'm running it, we get different outcomes just like that. So that's how that goes. So now let's talk about those methods we can use in it. So we have talked about type of, that tells us the type of stuff we deal with. Now let's talk about add. I told you in the previous stuff, so I'm just gonna take this away. So let's work with only set1. So I told you that we can add and we can also remove, but we cannot change set stuff there. So how can we add? So for instance, I can add by saying set1 dot add. So in it I'll provide the particular element I want to add to my set. So I can just put we have coding, I can just put programming. I put programming there, so just like that. And if I clear and run this again, oh sorry, I need to run set print it out, print set1. So if I run this, you can see we have coding, technology, company, wasting, and we have the new stuff that we just add there, which is programming. And I'm very sure this programming will always take the last part. Let me run it again. If programming will take the last part, you can see this changed, but this programming is still constant. Let me run it again to see. So programming will still be always, wow, it changed. Wow, that's wonderful. That's a miracle. So it changed this time around, so that's great. So that's all my stuff. So that's it. So you can see we can add using this method, the add method to add. So you can see it's a method. It has been indicated that there's a method. So one of the method in a set function used to add stuff. So the next thing we can talk about is update. Update, we can use it to add a whole complete set to another. So maybe I remove this, and I told you if I print this, I update this together, there will be a duplicate. This technology, company, coding, so we'll still end up having the same output as wasting technology, company, coding, one without duplicate. So what I'm going to do to make that reality is better, I'll change this to a number. So maybe this will be sets of numbers. So here will be 4, here will be 8, here will be 16. So just like that. So now I'll get rid of this. The next thing I'm going to do is to join two sets together. To join two sets together, actually to copy it and paste into the set, or to update a set with another set, you use the update keyword. So I want to use from set 1, I want to update it, so update is another method. You can see sets with the union of itself and others, so it's going to bring everything in union. So if I do that and I provide the next set, which is set 2, set 2 like this, so, and I print set 1, which is this set here that I have meshed together. Let's see what happens. So I'm going to clear this. Okay, I'm going to run Python sets.py. So now you can see we have 2 for coding technology, 8 company, 16 and wasting here. So you can see that have updated this set with the new set I've just created with 8. You can see that. Again, there is this conflict or misunderstanding that happens between updates and let me just say join of set using union. So for instance, let's look at union, what union can do. So I'm just going to take this away. Let's see what union can do. So in union, for instance, I do set 1 dot union I put set 2 just like that, and I print set 1. This is what is going to happen. You'll notice that it prints back those stuff. It gave me only the value of set 1. But if, for instance, I assign it to a new set like set 3, then I put equals to symbol, whatever action that is here will be returned, will be stored inside set 3. So if I put set 3 here like that and run it, you can see everything is printed, including set 1 and set 2. So what's the difference? This will set this set 1, update is going to set set 1 to a new value by adding more things to set 1, but union is going to join two sets together and align them, return the value to a variable we are going to be creating. So you can see returns the union of sets, it returns, but update does not return the union of sets. Look at update does not update a set with a union of itself and others, it does not return. So this returns but this does not return. So this will return the value and store it in set 3, but this will automatically set the value to set 1. So take note of that. So you know that in set in mathematics we have union sets, intersects, and universal stuff like that and all that. So you can see that. So I expect not to see such this thing get confused with those two. That's why I need to bring that up. Very important. Okay, so the next one is, I've talked about the loop. The next one is to remove. So we can remove a set. We can remove a set. So let me see. For instance, in set 1, we want to remove coding. I want to remove coding. So set 1 dot remove. So I'm just going to provide a string, remove an element from a set. It must be a member of the set. So when I'm removing, that element must be a member of that set. If it's not a member of that set, then there will be a problem. So for instance, I want to remove coding. So coding. So coding is a member of set 1. As you can see it here, coding, we have coding here, and is a member of set 1. So when I run this, okay, you can see, and sorry, I didn't print set 1. Set 1 like that. So let me go ahead and print it. Okay, now you can see we have company, technology, wasting, but there is no coding. Coding is gone. Good. So there is another one that always conflicts with coding, just as union is conflicting with update. So it is known as discard. So it's known as discard. I want to know the difference between coding and discard. But first of all, the difference here is, now in coding, let me provide what is not part of this set. So let me provide something like wisdom, like that, and I try to run the set python.s. Yeah, you can see there is an error. Set.remove wisdom key, error key, wisdom. So provided a wrong value. But if it was something like set 1 dot discard, so I want to discard. Now let's go remove an element from a set if it's a member. If the element is not a member, do nothing. So even though if the element is not a member, nothing should happen. So we are not going to have an error. So we can put something like coding there. So we can go ahead and run it. You can see we have wasting company, technology, but the other one is gone. There's nothing like coding. So what about if we provide something like wisdom? So you see, nothing is going to happen if we provide a value like wisdom. can see we still have our technology, coding, listing, and company, and nothing's affected, so nothing happened, and we did not encounter an error. So that's the difference between discard and the remove. Now the other ones again we need to discuss about, apart from the remove, the other ones that are used to also remove but a bit different. So we have this also in JavaScript, and we also have this here in Python, which is pop. So for instance, I type set one dot pop. Okay, so this pops out stuff. So we also know that it's only 3 elements that will be there. So whenever I run this, you see we have company, listing, technology. If we run it again, we don't know which is the one that is going to be pop out. You can see we still have listing, company, and technology. Wow, let me run it again. So this time around we have technology, coding, and listing. So you can see we are not really sure what is going to pop out, but I think pop in JavaScript always get rid of the last element or the last member. Okay, so that's for pop. Now the funniest thing about pop is pop can store the value of whatever has been removed in a variable. So for instance, I want to see a particular stuff that have been deleted. I'll just put deleted item, deleted item. Okay, so I want to get to know what is deleted in our set. So I can just print using the f string. This I can just call deleted item. So let me use that. That should be a bit quicker. So you can see if we clear the screen, so this deleted item is storing the value of what has been removed from our set. So that's one funny aspect of that. It deletes it, but it still holds the value. So it's trying to tell you that the value is still saved with me, despite the fact that it's deleted. I hate that. You can see listing was deleted in the set, color, company, technology. So in this set, listing have been deleted. In our set 1, it's been deleted. So what we are left with is color, company, and technology, something like that. So that is that. So we can get that the value of what was deleted. Even though I get rid of this, I can still go ahead and run this again. You see, company was deleted. I can go run something else. Listing was deleted. So it prints a full code and what was deleted. So that is it. So that is for the other stuff, and now that's for pop. Now let's talk about clear. But before we proceed to clear, we want to know if remove can also do the same thing, whether remove also store data. I'm not sure it does that, so let me do that, because I end up having an error. So end up having an error. So remove does not store data on delete and print it out. It's not possible. So that's for pop. So then finally, under the removing, we're going to be talking about clear. So clear is used to empty a set. So whenever we don't want data in our set, we use the clear keyword to empty the set. So for instance, I can just put get rid of this. So in our set 1, I can just say set1 dot clear. So clear is going to remove every damn thing in the cell. So whenever I go ahead and run this, you can see we have an empty set with nothing inside. So it's empty. Let me see if I can provide. Doesn't work. Let me put it into 2. So the clear just work without any. We don't need to provide any parameter. It does not accept anything in it. So parameter should be empty. Okay, so that's for the clear. Then we move further. So in our previous class, before now, I've talked about the unions. The union, this thing, is used to join two sets together. Union. So union in sets, they will join all the sets together. So so just permit me. I'm just gonna copy this. I'm gonna bring it down here. So I'm just going to take this away. So now let's get started. So the union set, I told you, is going to merge two things together. And if for instance I provide a duplicate, so maybe I have 4 here, I have 8 here, and I have 8 here in this, so we know that 8 is the same, and I use the union to merge them together, though kind of be a problem. So in union, set 1 union, then the next set, I'm going to provide the next set, sets 2. So actually what's going to be printed out is I'm going to print every damn thing except omitting 1 8 and just providing us with just a single 8. So I'm just going to clear the screen and I'm going to run that, so you can see so here we have 8 wasting. Okay, sorry, I probably need to assign. Let me look at the value. It returns, so based on the fact that it returns, so I need to assign it to something different. So I'll create another stuff, call it set 3, because I said that before then. Sorry, now I can go ahead and print. So you can see we have 2, 4, 8 code, company, 16 and others, all of them together. So you see we only have one 8. The second 8 was not matched, it was omitted because they are the same. And for a certain case whereby we have 1, so maybe I'm going to get rid of 16 and I'm going to add true here, like that. So let me see if that's properly going to do. So you can see the what happened here. True was printed out. We have 1 here, 1 was omitted. We have true, wasting, 2, 4, 8, company, no 1, or we have 1 here. What happened? If I change this to a 0 and I put false, false is regarded as 0, so we might end up saying false without 0. So if I run this, you can see true, false, 2, 4, wasting 8, no 0. But if I get rid of this, probably we should get to see 1 and 0. So you can see 1 is there, 0 is there, because there is no comparing of boolean with those numbers. Okay, so these are for the union. Then the next one again we're going to be talking about is intersect. Intersect will only print those values that are equal. So for instance, we have let me get rid of this. So we have set 1 and set 2, and in set 1 we have we have Monday. So put that in quotes. I don't like spelling Monday in full. Monday, Tuesday, and Wednesday. So maybe these are the 3 days that a particular person goes to work, and another person goes to work on Thursday, Monday, and Wednesday. So if you are using the intersects to run your code, what happens is it's going to check for those that are the same. So what is going to be printed out is Wednesday, because Wednesday is in set 1 and it's also in set 2. Monday is in set 1 and it's also in set 2. So that's for the intersects, just like we do maths, set 3, so it's equals to set 1 intersection, so it always return. So I'm going to provide set 2, so return, so we need to assign it. So whenever I run this, Wednesday and Monday will print it out. So you can see Wednesday and Monday is printed out. So that's that for the intersects. We also have another one that's kind of looking for difference. So we call it symmetric underscore difference underscore update. So let's look at that. So for instance, we have set 1 dot symmetric underscore difference underscore updates that's it. So we are going to provide another one, which is set 2. Set 2. We want to know if it returns. So it does not return at all, it only updates based on difference. So based on no returns, I can put set 1 here. Set 1. So putting set 1 here, and I'm printing it out. Let's see what's going to happen. So you can see Thursday and Tuesday are not the same. In this first one, we have Tuesday, but in this other one there is no Tuesday. In the second one we have Thursday, but up here we don't have Thursday. So it look for what differentiates them. You understand? It look for what differentiates them. Okay. So that's the one that I think it's kind of opposite of intersection. Is the opposite of intersection. So if you actually want to return without, you don't want it to be to update, but you want to return something, so you can just get rid of this. So actually we have this, but I'm going to put that back, create something different. So let me take this out so you get to reference that later. So this is going to be a return, so returns this. So based on the fact that we have return here, so we can go ahead and equate it. Let's call it sets 3 is equals to, so I can come over here to the bottom side and put 3 there. So you can see that. Then you can go and run that. So you can see this also the difference. One is returnable and the other one updates the value, while the second one is returnable. So that's just the difference between the both. Okay, so we have 2 more to go, or 2 or 3 more to go. Now there's another one we refer to as let me see if I can remember, subsets, supersets, and joint sets. Okay, so let's see. So when we talk about subsets, the subset, superset, and joint set returns, they all returns values such as true and false. They return a boolean if a condition is met. So let's take a look and see how it works. So for instance, I'm going to create a set 3. I'm going to equate it because it returns a boolean. Let's say is subsets. Let me see that. Sorry. S1 dot is a subset. Good. Okay, so S1 is a subset of set 2. So is it true or false? So when we're talking about a subset, so for instance, a subset simply means we have days of the week. Day of week. Okay. So this days of the week is a set of days containing Monday, Tuesday, Tuesday, Thursday, Friday, Saturday, and finally Sunday. So this is, let me call it a universal set. So inside this set is either we have set 1 or we have set 2. So when we say it's a subset, that means set 1 might either be a child of set 2, which is not possible because it's not everything that is in set 1 that you find in set 2. So if we run this is going to return false. So let us run set 3. Set 3. So this is going to return a false. You can see we have false printed out because this condition is not true. Set 1 is not a child. When you say subset, subset means a child. So it's not a child of set 2. But set 1 is a child of days of the week because Monday is in the day of the week, Tuesday is also in the days of the week, Wednesday is also in the days of the week. So if I put this here and run it, we are going to get true. You can see true is printed out here. Let me clear my screen. So true is printed out there. You can see that there. But even if we change this to 2, it's also a child of the day of the week. We have Thursday there, which is this, Monday, which is this, Wednesday, which is this. So they are children of the days of the week. And if I run that also, we still get true. So another word you can also put it is, you can say set 3, set 3, I can say days of the week is a superset. Is a superset. So superset is a parent. Is the parent of set 1. So let's put it that way. So if we run this is going to return true. You can see it returns true. But if for instance I add something like 1 or something like KOM like that, and I run this for set 1, it will be an error because that child does not exist. See, we have false there. So you can see that stuff we are trying to talk about there. So that's for superset. So superset is something being a parent, subset is something being a child. Is this a child of days of the week? No, they have all the traits except com. So definitely this is not the child of this. But if this the child of this, yes, we have Thursday, Monday, and Wednesday, which are all the traits of this. So that is it for subsets and supersets. Okay, so the last one is disjoint set. Now what's disjoint set? This will return true whenever both stuff are not the same, both equation are not balanced. So if for instance in here we have Monday, Tuesday, Wednesday, let me get rid of this column, okay, and in this case we have Thursday, Friday, and Saturday, like that, and we create a new set called set 3, and we equate it to set 1 dot is disjointed to set 2. So let's see what our output is going to be. It's true because they are not sharing data. Even if I change this to set 2 is disjointed to set 1, this is going to return true. What if I say set 2 is disjointed to set 2? Let's see what's going to happen. False, because what is in set 2 is also what is in set 2. So that is all for sets. So please make sure you subscribe, you like and share. So if there's anything I'm missing that I've not added, please make sure you put it there. You drop it on the comment section. I will really appreciate your contribution. It goes a long way. And please, if you are a new viewer, please make sure you subscribe if this really makes a whole lot of sense. And if you are a member, my subscriber, I give you a thumbs up. God bless you, and see you in our next class. Thanks.